Hi, grade 9s. This week we're going to start looking at how to find equations from scenarios and from tables. So part of today's lesson is going to be similar to what we worked on with the linear stuff before the break. So we have a word problem here, and we're going to talk about how to find an equation for that and how to fill in the table. The last step we're going to do is talk about how we can get an equation just from the table, because we've looked more at word problems where we figure out what the equation might be from the words in the question, but we want to connect that today to the table as well. So what I want to look at first here, Big Pine Outfitters charges a base fee of $30 to deliver the canoe to the launch site and $10 per hour of use. So that per hour, we've seen that before. When I see something that says per, I know that that's like a unit rate. So they're going to charge you $10 for each hour that you rent the canoe, plus they charge you a fee of $30 to deliver the canoe to your site. So what we're asked to do over here is to find two different things. The first thing, we're looking for what's going to be called the rate of change. And that's a really important thing that we're going to talk a lot more about over the next couple weeks. In this case, today's lesson, we have written in for you guys what that rate of change represents in each scenario that you're going to do for homework. So here, the rate of change is the cost per hour. So if I look back up to my question, I have two numbers. I have a $30 delivery fee and a $10 per hour. This is the rate of change here. That's going to be $10 per hour. So that's the unit rate for renting the canoe. The second thing we're going to be looking at is, in general, we're going to call that an initial value. Here, in this question, it's called the base fee. So what is the base fee of delivering the canoe? Here, it's that $30. So I'm going to put $30 here. Now, you guys have done this before and looked at how could I come up with an equation to represent this? So you know that each time you rent a canoe, you're going to pay $30 for the delivery plus $10 each hour. So I could come up with an equation. What I would be figuring out here is cost. So I like to use the letter from the thing that I'm going to be figuring out, and that's a C for cost. I'm just going to kind of put an arrow here and call that cost. So my cost of renting the canoe is the $30 base fee plus, and then I have a unit rate, $10 per hour. If you rented a canoe for 5 hours, you would have to count that $10 on 5 times. So you would do $10 times the 5 hours. So I'm going to write the equation as 10 times n. Remember that it's multiplication here if you don't have an operation between a number and a variable. And just like I labeled the C as cost, I'm going to tell what n is. And you can see in the table, that's my first letter there. That's the number of hours. So now that I've done that, I want to come up with the table that would represent this situation. So we've got the left-hand column filled in. It asks for what's the cost for 0 hours, 2 hours, 4 hours, 6 hours, 8 hours, and 12 hours. So each time I'm going to use this equation to come up with the cost. So here I've got $30 plus $10 per hour times 0 hours. If I do that math, remember that you have to do order of operations. So you will multiply this first. If you type this all into your calculator, make sure that you're using order of operations here. So 30 plus 10 times 0 is 0. So this would cost $30. which seems a little bit silly that you would have to pay $30 to rent a canoe for 0 hours. But say, for example, if the guy put the canoe on his truck and drove it to the lake for you and you said, I don't feel like canoeing today, he's still going to charge you $30 because he still put the canoe in his truck and drove it there for you, even if you don't use it. So then the next one, if you rent the canoe for 2 hours, you're going to pay that $30 rental fee or delivery fee plus $10 per hour times the 2 hours that you're renting the canoe. So 30 plus $10 times 2, 10 times 2 is $20. So 30 plus 20, you're going to rent the canoe for a total of $50 for 2 hours. We can keep going here. The next one, 30 plus 10 times 4 hours. You want to have a longer canoe ride, you're renting it for 4 hours. 10 times 4 is 40. 30 plus 40 is 70. Now, I think you guys are probably seeing a pattern in here, and that's awesome. And I bet a lot of you just want to say, oh, 30, 50, 70. Do we think this is going to be 90? It is. We'll figure it out. But if we pattern this out, you have to be really careful because sometimes the number of hours or the first column is not going up by the same amount. So you have to watch that and don't just kind of fill it in based on a pattern you see. You have to actually figure out each one. So 30 plus 10 times 6. 10 times 6 is 60. Add on that 30 and you've got that 90, just like we saw from the pattern. The next one, 30 plus 10 times 8. 10 times 8 is 80. Plus the 30 here, we've got 110. And the last one, this is why we can't just say 30 plus 20 plus 20 plus 20 plus 20 and fill this in with the pattern. You will notice that it's not the same pattern on the left. So if I do 30 plus 10 times 12, 10 times 12 is 120. And add on that 30, we get 150. So here we have our table of values. Now what we're really going to do today that's new is to find the equation from the table of values. How could we come up with these things? Where do we see this $10 per hour from our table? Where do we see the $30 initial value from our table? So what we want to do is look at a few things. We're going to start with this initial value. So I want to really kind of highlight this. The initial value was the base fee. So my initial value here, we said that that was the base fee of $30. Where do we see that in the table? The initial value is always when it starts at 0. So here, where you have 0 hours of rental, we see that 30, that's my initial value. So the 30 here is your initial. So we always in the table want to look for where the 0 is in the left column, and the number there in the right, that will be your initial value. The second piece, this rate of change, this is where some of you guys may remember this from before the break, but there's a new formula today. So this really important formula for the rest of this unit, we're going to make a short form for rate of change just with the initials. It's equal to what's called rise over run. So the rise means how much you're going up by, and the run means how much you're going across by. So in this situation, and the rate of change is our unit rate. So what we're going to do to figure out the rise and the run is looking at our table. We know that if we graphed this, the cost would be going up and down, and the number of hours would be going across. So cost is the going up and down part. That's rise. Rise means going up and down, and run means going across. So cost is going up and down, number of hours is going across. So I'm going to find the rise by looking at how much the cost is increasing by each time. And that is that pattern that you guys maybe recognize. So here, going from $30 to $50, that went up by $20. Then going from $50 to $70, what did that go up by? $20 again. If you're ever a bit stuck with the numbers, these ones I think are pretty easy to see. You can always subtract. Take the bottom one, subtract the top one. So 30 up to 50, that's increasing by 20 because you could do 50 minus 30 is 20. 70 minus 50 is 20. If you just see the pattern of how much it's going up by, that's probably easier for most times. But if the numbers were a bit messy, you subtract. So 110 minus 90, that tells us it's going up 20. But something different happens here. Something here happens. Remember, it didn't follow that pattern. That's okay. Here, 110 to 150, that went up by 40. So this, how much it's going up by each time, this tells me the rise. Now, on the other side, the number of hours on a graph, that tells you how much it would be going across by. And what we want to look at is how much is that changing each time. So we're going to do the same over here, but what we're finding, so let me shift my paper a little bit. What we're finding on this side of the table is the run. It's how far over it would be going. That's by number of hours. So how far over is it going between 0 hours and 2 hours? It's going over 2 squares, 2. How far over is it going between 2 and 4? 2 again. How far over is it going between 4 and 6? 2 again. And then between 6 and 8, we're going over 2 again. The last one, just like on the right-hand side, this last one's a little bit different. How far does it go between 8 and 12? You can count up 4 to get from 8 to 12, or you can do 12 minus 8 is 4. So when we want to calculate the rate of change, we pick a number in the rise and divide it by the number across from it in the run. And most of these are 20 divided by 2. So I'm going to go 20 over 2, which is $10 per hour. It's how much divided by how many. This went up by $20 divided by 2 hours. That's our unit rate. So it's really like finding a unit rate from the table. So you hopefully can see the connection here that when we have, going back to my initial, the initial value of 30, that goes in your equation as the first thing. That's where it starts at. Then we find the rate of change from the graph or from the table, and that ends up being 10, and that was the second thing that was multiplied by the number of hours. So you see how the initial and the rate of change end up in the equation. Just a little note, if we had done this 40 and 4, rate of change, remember, is rise over run. What happens here? You've got 40 divided by 4. That's also 10. So you actually get the same rate of change whether you go with all these 20 and 2, 20 and 2, or the last one where it was a different size of jump. Now, I know that you guys can come up with the rate of change and the initial value from the scenario. So my rate of change in the scenario was the unit rate that cost per hour. So I see the rate of change in the scenario, but I want to make sure that you guys can also come up with the rate of change from the table, because tomorrow, in tomorrow's note, you guys are going to have just the table to come up with the initial and rate of change and not have a written scenario. So you'll have to kind of get the equation using the table. So when you're doing the homework today, I want you guys to go through all the same work that I did, filling in the table, finding the rise, finding the run, and then using that to calculate rate of change for each question.